Alright, so let's look at number 12. So the first thing we're going to do, it said, is to find our domain. So to find the domain, remember it's a fraction, so it's where our denominator cannot equal 0. And so x squared minus 4 cannot equal 0. And since I'm going to have to factor this anyways to find holes in vertical asymptotes, I'm just going to go ahead and factor this. So this is x plus 2 times x minus 2 can equal 0, which tells me x cannot equal negative 2 and x cannot equal positive 2. So my domain then is going to be from negative infinity to negative 2, negative 2 to positive 2, and positive 2 to infinity. And remember, use your number line if you need to see that. So now, though, I have factored this denominator, and we said it was x plus 2, x minus 2, because there's a difference of squares. And I'm about to do my vertical asymptotes of my holes, so I need to also go ahead and factor the numerator. So I know it's going to be x and x. They multiply to 12 and subtract to 1, so 4 and 3, plus and minus. Alright, so when I go to do my vertical asymptotes and holes, step 2, I'm going to go ahead and do my holes first again. So when I look up there, does anything cancel out? Nothing cancels out, so therefore there are no holes. Now when I go to do the vertical asymptote, that means that both of those denominators, where they're equal to 0, is going to be my vertical asymptote. So x plus 2 times x minus 2, it's where it's equal to 0, which is at negative 2 and positive 2. So these are both going to be my vertical asymptotes. So then we have our horizontal asymptote is next. So the horizontal asymptote, remember, is where your highest power of x is at. So I'm going to go back to the original one because it's easier to see it like this. So my largest on top is x squared and the largest on bottom is x squared. Therefore, it's on both of them. And if it's both, remember that's where we use the y equals a over b, where a and b are the coefficients in front of it. So in front of the first one, the top one, I have a 1. In front of the denominator's one, I have a 1. 1 over 1 is 1. So I have a horizontal asymptote at y equals 1. And then we need to check. Step 4 says to check and make sure that see if it crosses it. So you're going to set your function, and I'm going to go ahead and just use the original one since nothing canceled. So the x squared plus x minus 12 over x squared minus 4, I'm going to set that equal to 1. And so I'm going to multiply by the x squared minus 4 to get rid of it. And so I get x squared plus x minus 12 equals x squared minus 4. My x squares will cancel when I subtract them over. And so I have x minus 12 equals negative 4. Add the 12 and we get x equals 8. So we are going to cross this, we are going to cross this horizontal asymptote at the ordered pair 8, well, the vertical asymptote is at y equals 1, so my y is going to be 1. So we will cross at that ordered pair. Alright, then we got to do our x and y intercepts. And let's see, it asks for y-intercepts first. That's step 5. And it doesn't really matter what order you do it in as long as you do them all, but I'm trying to stay in with the steps. So for the y-intercept, remember that's where x equals 0. So I'm going to go back to the original one again since nothing canceled. And so we got y equals, it's going to be 0 squared plus 0 minus 12 over 0 squared minus 4. So I end up with negative 12 over negative 4, which is positive 3. So I have the y-intercept at 0, 3. And then I got to find my x-intercepts. So x-intercept is where the numerator is equal to 0. But if I go ahead and use the original, I'm going to have to factor it anyway. So it's going to be where x plus 4 times x minus 3 is equal to 0, which is where x equals negative 4 and where x equals 3. So I have two x-intercepts at negative 4, 0 and at 3, 0. And so I'm going to go ahead and graph those because to me it helps to see them when I go to do my, my table for number 7. So, but I do want to be careful because I see it crosses out at 8, 1. So I need to make sure that I can do that. So I'm going to move that y-axis towards the left just a little bit more than normal. All right, so there's my x-axis. And so I'm going to do my y-axis over here. So let's see, we have no holes. We have vertical asymptotes at -2 and +2. We have a horizontal asymptote at 1. And this is going to actually cross at 8, 1. So I'm going to go put that point there. So I'm going to change colors. We'll graph it in blue. So 1, 2, 3, 4, 5, 6, 7, 8. So right there it's going to cross it. What else? We have Y-Intercept at 0, 3. That's a point on the graph, so I'll put it in blue. And then X-Intercepts at -4 and +3. All right. So then I can see if I'm going to make my table. Remember, you have your intervals. You're going to have your x value. I'm going to kind of abbreviate this time since we've already made it once before. We're going to have the y value. And then I'm going to go ahead and put the sign because the sign is really going to be useful in the next one. But this is the way we're used to making this table because we have to remember how to do it. All right, so I can either make a number line or I can actually just look at my x-axis. As I go across there, I can see that it's going to start at -infinity. And I have an x-intercept at -4. And then from -4, it's going to go to the vertical asymptote at -2. From the vertical asymptote at -2, it goes to a vertical asymptote at +2. And from +2, it's going to go to the x-intercept at 3. And then from 3, it's going to keep going to infinity. Alright, so we have a little work to do on this one. So I'm going to pick some x values. So how about -5, -3, 0. Guys, -2 to 2, if 0 is in that interval, use it. It's already your y-intercept, so you already know the answer there. So because I picked 0, I know the answer is going to be 3, which is positive because that's what my y-intercept was. 2 to 3, so I know I have to pick a fraction, a decimal, but that's okay. And 3 to infinity, so I'll pick 4. Alright, so I'm extend this a little bit here. Alright, so I'm going to have to plug all of those in. So it's up to you whether you use the original or the factored form. If you have the calculator, your original is probably the easiest. If not, your factored form doesn't really matter though, because if you're using your calculator, you'll be fine. If not, I'm going to show you how to do it without a calculator, and then I'm going to plug them in my calculator to figure them out. Alright, so without a calculator, I'm probably going to use the factored form. So my first x that I'm going to plug in is -5. So it would be -5 plus 4 times -5 minus 3 over -5 plus 2 and -5 minus 2. And so I'll work this out. I get -1 times -8 over -3 times -7. And so when I work that on out, I get 8 over 21, and that doesn't reduce. So it's just a really, really small number there. Okay, so 8 over 21. Well, it's not super small. It's what? Almost a half, but not quite. So if you need to, you could put that as a decimal, which, alright, so when I put this in my calculator, it comes up to about 0.38. So if you need that to help you, you can. Otherwise, a fraction's fine. So 0.38, and it's positive. Alright, so we're going to go through and we're going to plug in -3, 0, 2.5, and 4. Now, well, we already did the 0 though. So I'm going to go ahead and plug in my -3. I'm not going to write it down because I'm short on room. And I got -1.2, which is negative. We already did the 0 because that was our Y-intercept. So I'll plug in my 2.5. And I got approximately -1.44. And then when I plug in 4, I ended up with 0.67. So that was negative and this is positive. Now most of the time, they will alternate plus or minus signs, but not always. So I'm going to graph these points to help me out. So I had -5 and 0.38. 0.38, excuse me. So it's going to be somewhere like right there. I have -3 and -1.2. So somewhere in there. 0, 3, we already did. 2.5 and -1.44. So somewhere in there. And 4 and 0.67. Alright, so to the left there we can kind of see how our graph is being shaped by our asymptotes. Now, in the middle there we have that one point. Well, let's think about this. If it was going to go down, it would have to cross that horizontal asymptote, which means we should have found it when we did step 4. And it would also have to cross the x-axis, which means then I would have more x-intercepts and I don't. So this in-between must be going to go up since they didn't give me either of those. And then here I can see coming out of that x-intercept at 3, going towards that asymptote, it's going to go down. Now, watch this because this is what's really kind of tricky. Because we're going to come up to this horizontal asymptote, we're actually going to cross it, but then we're going to curve back down towards it. Now I did a little dramatic there. It wouldn't have been such a big curve actually. So it just barely goes up and then it just kind of comes back down towards it, where it's not really lying on it, but it's really super close to it. And so there's the graph of my function.